most available.
Okay. Hey,
you know,
I'm Chet. This is Julian.
Hey.
We're gonna walk through rail stuff.
Yeah. So yeah, I'm just going to go over some of the basic mechanical and then a little bit of electrical, but most of it's kind of obscure just because it's hidden in shrouds, so I don't really want to take them off. Yeah, so mechanically wise, the whole thing, the way this works is that you basically have a square, so this is the gantry. It's cantilevered out against itself, so you can see how this is actually one of the problems that I'm going to have to talk about. I'm going to be working on in the future is that, so one of the strengths is that it's great for reducing material usage because you only have one bar going across, so that's only like, you only have these parts
Yeah.
to make it sturdy. But the problem is that since we've made it so long, and since the design requirements are just so massive, you have this effect.
Yeah.
When you have force on it. Now under normal circumstances in a greenhouse, you won't have that because the only force acting on it should be itself, but under like you put it outside or there's wind or someone smacks it, suddenly you have a lot of vibrations and you got oscillations. But anyway, yeah, we'll go into that. There's a potential fix for that. But the basic idea is that you have a static belt rail going along the side here, and that's made of, this stuff is GT2, so this is the belt profile, and that's interlocked with another of the same kind of belt, but a closed loop around this servo, or I guess it's a stepper motor.
Yeah, it's a stepper motor. Yeah, so take a look at this.
Yeah, and the way that works is that we basically just kind of press the stepper, or press the second belt, which I'm calling the dynamic belt, against the static belt so it interlocks. And actually, if you want to get a shot right here, you can kind of see this is the effect we're going for, is that all these teeth are interlocking with each other.
Yeah, where's your finger at here?
Oh, sorry, just down through. You have to go through the Ethernet, because you can see that this belt is interlocked with the other belts, and it's hard to see with the wheels.
There's a black belt interlocking with the white belt.
Yeah, exactly.
And that's like on this little mechanism right here.
Yeah, and so this mechanism, and actually let me turn it off so that way I can backturn it. And the way this works is that the motor, and actually if you want to come on
come over this side.
So the motor right here, you can see has the belt interlocked on this pulley, and as you move the motor back and forth, the whole thing moves because this carriage is free to move. These wheels are made of, they're Delrin bearing wheels, the ones you get on 3D printers all the time, but they're really great for resistance on aluminum, so they don't have a very high resistance for static or dynamic, and also the bearings are really nice in them, so that's why I use them. So they're free to move, but the thing that's statically locked is this belt in place, and so as long as this belt moves, the whole thing moves, like that.
Great.
And the way we create tension, and that's kind of the hardest part of this, that's like the key, is that you really have to get a lot of tension on this belt and a lot of, not adhesion, but a lot of meshing, I'm going to say, in between these two belt layers. Because otherwise, if you don't have mesh, then you're not going to have the belt move. And that's what these two kind of 3D printed wheels are for. So there's two bearings in there, and the reason they're 3D printed is because they have to be a very specific size. It's not like, you know, a couple millimeters tolerance, but it has to be more specific than what I had available on online.
Really?
And so yeah, because these wheels are about 24 millimeters, and the bearings I could get for this size that fit M5, so that's what's going across here, could not actually, they don't touch the belt. They don't push the belt far enough down.
Yeah.
And so that was the problem.
I see.
Yeah, let me actually get let me show you real fast. I can do this. So anyway, so those are 3D printed. They're just around standard bearings. There are little flange bearings inside there, and I'm gonna take them off. I'm gonna show you, just because it's good to know. So these whole things, the way they work is there are two 45 millimeter bolts that go in between here, and in the middle they touch at this heat set. Normally those heat sets aren't supposed to be there. They're supposed to be bolts or like hex nuts, like of a specific size. But these heat sets were cheap, and then they're the same size that I need. They're 8 millimeters.
And by heat set, you mean like brass heat set inserts?
Yeah, inserts. Yeah, exactly.
Okay, so there's currently these inserts.
Yeah, the whole point is that you just need something threaded in here that's M5 that you can then thread everything together, and it basically compresses the whole carriage together. Okay. And actually, oh man, I have to do this too. But yeah, so that's what these do, and the reason that they have those in the center there is because there are two sides to this carriage, and we need them to compress together so that way you keep the whole thing rigid. Right. And so that's what those heat sets do. Okay, on the back here, if you didn't see it, there's two slides right here. These keep tension on the belt, so you can just move it up and down. So that way you can put dynamic belts on here, so you can choose like smaller size, bigger size, whatever, and all you have to do is push this up until the tension is met. And so basically, the way to test it is basically when you push your finger, the amount of deflection you get is how you want to do that. There's a way to test that more mathematically, but I don't have the tool with me right now, so what I've been doing is just a finger test.
Cool.
So,
So anyway, so those are pretty printed. They're just around standard bearings. They're little flange bearings inside there, and I don't take my off. Yeah, I think even for 3D printers, they have like the pluck test where like if you pluck the bell, it should sound like a guitar string.
Yeah, exactly.
It doesn't tell you what pitch though.
Yeah. They have those on Amazon, which I was thinking about buying. But also, if you want to see what I'm doing here, so on this other side, so there's two sides to this. There's two different kinds of wheels. So this wheel is more of just this is an idler really. It's just keeping tension on everything. And the way it keeps tension is that there is a very small bolt, or as long as like 2 bolts and a nut that clamp basically this side onto the rail. So if you want to, like, I don't know if you can go in the top there.
Yeah, okay.
Yeah, you see that this guy right here. So in between here, there's a little nut. There's a hex nut. That's I think 30 millimeters.
Oh, you mean like that big silver hex nut?
Yeah.
Okay.
And on the bottom and top of these, there's 2 bolts, and as you screw these bolts in, they clamp both sides down, and that's what keeps it stable on the rail.
All right.
And also it keeps tension on the belt here. Same thing I was talking about before, is that if you push this whole thing down with these 2 bolts, you keep pressure on the belt so that way it doesn't slip off.
Cool.
So anyway, sorry, I'm just loosening them because it's a whole thing to get one of these wheels off. But I think it's important to see what's inside. So if I loosen everything, you can move everything up and down, and now there we go. Now I can just take this off. Hopefully, there we go. So inside there, you can see that that's what it is. Just a little bearing. So there's a little flange bearing. You can pop it out of the 3D print.
Okay.
Maybe I might have tightened them in a little bit too much, but normally you can just pop them out, and then if you want to put them back in, then they just slide right in here. And you can see there's a flange on this one too, and that's what keeps the belt in. So that keeps the belt on the rail. Because this tiny belt is going to want to slip off. It's just like in the nature of it. Let me see if I can put everything back together. There we go.
Yeah, it would be really handy to have like a sort of a, from scrap parts.
Yes,
how to assemble the whole carriage.
Yes.
Especially for like any future mechanical teams.
And that is in the works.
Nice. Yeah, let me know if you need like a student to help just hold a camera, like a selfie stick. Because it helps to have like both hands free and have someone else just kind of.
Yeah. So I guess, see, I'm tightening this back down. This is as long as this belt is in between those flanges, then as long as you can tighten it down, you can tighten everything else around it.
Okay.
And just tighten these on the hex nuts.
Now, before you tighten the belt down, you also have to like kind of move your finger along to make sure that.
Yeah, it definitely helps. Actually, let's see. Is that too much? And there's not a lot you need to do on this side. As long as it is interlocking, then as you push up.
Yeah, it'll compress the teeth.
Yeah, it'll compress the teeth.
Yeah.
You're right. Let me loosen this.
Yeah, you definitely don't want like an additional tooth in there or something.
And you definitely have to use GT2 for the belt profile. Some people online said that you could use HTD 3 or 2.5 or something. There's a metric and an imperial. One is like 2.0 millimeters and one's exactly 2 millimeters. And I got burned because someone's like, oh yeah, you can totally interchange them. You cannot interchange them. So that very small difference as it percolates down means the belt every other like 50 teeth will skip. Yeah. And that's really bad. So I learned that the hard way. Okay, there we go. There we go. So tighten this guy down. See if I can get just as long as it's interlocked. There you go. And now we can compress this guy. Hopefully I can get these interlocked together. Come on. There you go. And
so you get your tension first and then you compress it down?
Yeah, because that way that keeps it in the middle here.
Uh-huh.
Yeah, or in the middle there's tension. And yeah, if you can see here, it's easier than using my finger. I can tighten them down a bit faster.
Yeah, so you use the Allen wrench on one end and
a screw on the other.
Yeah, okay.
As long as it's not too much. You also have to be careful not to put too much force onto these wheels because the friction, if you put too much, does cause problems. But
I see.
For the most part.
So there's a sweet spot. You want them to be tight, but not too tight.
You want it to be tight, but also free to move. So if you can go like this, then you're good. But if you tighten it down too far, it'll be really hard to move it.
And if you see like a little bit of daylight in between the teeth, is that okay?
Yeah,
so for example,
usually that's okay because a lot of what this does is that the actual tensioning force comes from these guys right here. So as long as these guys are pushed down and meshed, that's all you need.
You're good.
This is just extra. Like if you get those interlocked, great. But otherwise, this is where all the this is forcing it into the teeth. So
yeah, right. So as long as those wheels are these, what do you call them, bearings?
Yeah, I'm gonna call these are bearings. Idlers is really what they're supposed to be called, but
all right. Okay.
bearing, but yeah.
Cool. That's
Yeah.
fun. Thank you for that overview.
Yeah.
Here, let me save this file. Let's